Do we need to change our theory of the structure of the universe? Astronomers have discovered a ring of galaxies with a diameter of 1.3 billion light-years. The existence of such gigantic structures suggests that something may be wrong with the current theory. At the very thought of it, scientists' excitement reaches its peak. What is this all about? What is the newly discovered Great Ring? It is an unusual concentration of galaxies located about 9.2 billion light-years from Earth, which we could observe near the handle of the Big Dipper. We could, if not for the fact that it is such a faint object that specialized equipment is required to notice it at all. Interestingly, this region appears to be rich in enormous structures, because a little farther away one can find the so-called Great or Giant Arc, another unusual and enormous concentration of galaxies. And this is the real problem, because such huge structures contradict the so-called strong cosmological principle, which states that the universe is isotropic, meaning it has the same structure regardless of the direction in which we look. But wait, this is where alarms about Illuminati and Soros-funded pseudoscience immediately go off. Strangely enough, both transfers come from the same account. How is the universe supposed to be homogeneous in every direction when all it takes is a glance at the night sky to see that in one place there are more stars than in another? In one region we find a nebula, in another we do not. After all, there is far less matter outside galaxies than inside them. A fair point. This principle applies to enormous distances. On average, on very large scales, matter should be distributed evenly. What distances are we talking about? Calculations within the currently most widely accepted model of the universe, the Lambda-CDM model, point to scales of about 1 billion light-years. So if we divide the observable universe into regions with diameters slightly over 1 billion light-years, each should contain roughly the same amount of matter. And here the problem becomes obvious. If the distribution is supposed to be uniform, how can structures larger than 1 billion light-years exist? And let me remind you that the Great Ring, with a diameter of 1.3 billion light-years, is not unique. Astronomers have also discovered other gigastructures, such as the Great Wall Sloan, a concentration of superclusters of galaxies stretching nearly 1.4 billion light-years. Another example is a group of 34 quasars extending over 2 billion light-years, known as the Claus-Camposano LQG. Even larger are the previously mentioned Great Arc, with a length of 3.3 billion light-years, and the huge Large Quasar Group, with a diameter of 5 billion light-years. As we can see, there are many places in the cosmos that challenge either the current model of the universe, Lambda-CDM, or the cosmological principles themselves. It is also worth explaining what the Lambda-CDM model is. Lambda refers to the cosmological constant, which today is associated with dark energy, believed to be responsible for the accelerating expansion of the universe. CDM stands for cold dark matter, which is thought to make up most of the matter in the universe, but interacts with baryonic matter only through gravity. All the calculations and assumptions pointing to the existence of these two phenomena together form the Lambda-CDM model. It is not the only model, but it is the most widely supported and the one that best matches observations. And yet something must be wrong, either with it or with the cosmological constant or with both. Otherwise, we would not observe such enormous structures in the universe. Let us dive deeper into this topic. The Great Ring is located 9.2 billion light-years from Earth. It has a diameter of about 1.3 billion light-years and a circumference of around 4 billion light-years. If we could see it directly, its diameter would cover an area of the sky equivalent to about 15 full moons. It is the second ultra-large structure discovered by a PhD student at the University of Central Lancashire, Elijah Lopez, who 2 years earlier also discovered the Giant Arc. Remarkably, the Great Ring and the Giant Arc are located in the same cosmological neighborhood. They are seen at the same distance, at the same cosmic time, and are separated by only 12 degrees on the sky. Lopez stated that neither of these two ultra-large structures is easy to explain within our current understanding of the universe, and that their enormous sizes, distinctive shapes, and cosmological proximity must certainly be telling us something important. One possibility is that the Great Ring is related to so-called baryon acoustic oscillations, or BAO. These would have formed in the early universe when it was still a dense and hot plasma, and today should manifest statistically as spherical shells in the distribution of galaxies. However, a detailed analysis of the Great Ring has shown that it does not fit the BAO explanation. It is too large and not spherical. Astronomers suggest that another theory may provide an explanation: conformal cyclic cosmology, or CCC. This theory was proposed by Nobel Prize laureate Sir Roger Penrose. Rings in the universe could indeed be signals of CCC. Such enormous structures could be the result of a repeatedly occurring cycle of expansion and contraction of the universe. The contracting universe would compress these anomalies together, and after re-expansion, matter in those regions would once again become more densely concentrated, on scales larger than 1.3 billion light-years. However, statistically speaking, we might expect perhaps one extremely large structure in our observable universe. Yet the Great Ring and the Giant Arc are two huge structures, and they are even cosmological neighbors, which is extremely fascinating. And let me remind you that these are not the only enormous structures discovered in the sky. Another explanation may be related to the effect of cosmic strings passing through the universe. Cosmic strings are filament-like topological defects on enormous scales that could have formed in the early universe, but once again this is only a hypothesis, based solely on mathematical calculations and not yet supported by observations. Another Nobel Prize laureate, Jim Peebles, has recently suggested that cosmic strings may play a role in the origin of certain features in the large-scale distribution of galaxies. This may sound very strange. Giant cosmic strings. What is all this about? But if the Big Bang theory does indeed describe the beginning of our universe, as all evidence suggests, we must remember that these processes occurred on extremely small scales at the beginning. These were almost quantum-scale irregularities which, after the expansion of space-time, grew into enormous structures. However, such large structures, along with others found by cosmologists, question our idea of what an average region of space looks like. Let me also remind you that the cosmological principle assumes that the part of the universe we can see is a good sample of what we should expect from the rest of the universe. We expect matter to be evenly distributed everywhere in space when we look at the universe on large scales, so there should be no noticeable irregularities above a certain size. Cosmologists calculate the current theoretical upper limit for the size of structures at about 1.2 billion light-years, with decimals, of course, and both of these structures are significantly larger. The Great Ring appears to be almost a perfect ring on the sky, but further analysis by Alessia revealed that it has more of a spiral shape, like a corkscrew, oriented face-on toward Earth. The Giant Arc, which spans about 1.15 times the radius of the observable universe, appears as a huge, nearly symmetrical crescent of galaxies in the distant universe. It is twice as large as the much closer Sloan Great Wall. The Great Ring and the Giant Arc are at the same distance from us, which means they existed at the same cosmic time, when the universe was only half its current age. Identifying two extraordinarily ultra-large structures in such close proximity raises the question of whether together they form an even more extraordinary cosmological system. And the data we are looking at come from so far away that they needed half the lifetime of the universe to reach us. They therefore originate from a time when the universe was about 1.8 times smaller than it is today. And how were these discoveries made in the first place? This is also very interesting, and the answer may lie in whether the cosmological model is truly under threat. As mentioned earlier, these structures are so faint that it is extremely difficult to observe them directly. To do so, a clever trick was required. Alessia, together with her advisor Dr. Roger Close, both from the Jeremiah Horrocks Institute at UCLAN, and collaborator Gerard Williger from the University of Louisville in the USA, discovered the new structure by analyzing absorption lines in quasar spectra from the Sloan Digital Sky Survey. Using the same method that led to the discovery of the Giant Arc, they observed intervening MG2 absorption systems illuminated by quasars, which are distant, extremely bright, active galaxies. These very distant, very bright quasars act like giant flashlights, shining through distant but much fainter intervening galaxies, which would otherwise remain unnoticed. By calculating how much light was absorbed along the way, it is possible to trace the shadow of the objects lying in front of them. In doing so, the enormous ring and parts of other gigastructures were revealed. As we can see, this is also a place where mistakes are easy to make. Alessia presented her findings on the Great Ring at the 243rd meeting of the American Astronomical Society on January 10, 2024. This body invites researchers with potentially groundbreaking discoveries to share their work with the global astronomical community. And if you want to discover even more cosmic news, I invite you to subscribe.